Alright, gang, this is the sample test for Precalculus Unit 3. Starts off with a few problems that want you to solve the triangle. And when you look at what you are given, angle A, angle B, and angle A, if you're given two angles right away, if you're given like 2 out of the 3 angles, just subtract them from the full 180 degrees to figure out the third and final angle. So angle C should be 78 degrees. And then what you have to do is the law of sines. Okay, so you only have one side that you know right now. It's side A. So one of your proportions is going to have to be the A proportion. You know, it'll be little a over the sine of big A. And then I think you kind of have your choice, right? As I look at this. Yeah, you could choose whichever one you wanted, but one of the fractions definitely needs to be the one that involves the A's. So here we go. We have A over the sine of A, or lowercase a over the sine of uppercase A, equals B over the sine of B, and then we cross multiply to get that. I'll just kind of recall that cross multiplying means like you're multiplying diagonally like that, and you're getting this. And then what you want to do is solve for little b by dividing both sides by the sine of 34 degrees. And so this is what you're probably going to put into your calculator all at the same time and get an approximated answer of that. And then you're going to have to use the law of sines again, but this time to find little c. I'm going to use the A's fraction again, and then the C's fraction. Plug in what you know, cross multiply, divide both sides by the sine of 34, and that'll get little c by itself. Remember, there's no need to do any inverse sine here, or like there was no need to do any inverse sine up here either. You just can get c by itself straight up and you're done. And when you throw this into your calculator, you get about 8.396 for little c. And so that's how number 1 plays out. In number 2, they give you big C, little a, and little c. And we only have one angle, so we can't find, it's not like we have 2 angles right off the bat, and then we have to, or then we should find the third angle quick and easy. But what could we do here? Could we do the law of sines? Yes, because we have both c's. So that would make one fraction and complete, with both c's. And then we have little a, which means we can find big A with the law of sines. So you set up that proportion, A over the sine of A, and we don't know big A, equals C over the sine of C. We cross multiply to get to there. And then all we can really do is get the sine of A by itself. It's not gonna be that simple to get big A by itself. We're going to have to get the sine of A by itself. And then what are we going to do to find what big A is? What are you going to do? Well, we're going to do the inverse sine. of this whole fraction. Make sure you use parentheses where you should, like if you're plugging this into your calculator, don't forget to close up that 48 in parentheses, and there's probably going to be a set of parentheses around kind of like the whole thing, I guess. But you definitely are going to need to close the parentheses around the 48 as you do, again, the inverse sign. Your calculator is going to tell you this, but you have to remember at this moment that when you're doing inverse sine, you know, there are two answers. Or for these problems, there's going to be two answers in between 0 and 360. Okay, or to be more specific, when you're doing inverse sine, there's going to be an answer in quadrant 1, which your calculator will tell you. But there's also a potential answer, another potential answer in quadrant 2. And here's a reminder that in order to get this, all you have to do is do 180 minus this. So again, this is what your calculator will tell you, the quadrant 1 answer. The quadrant 2 answer is 180 minus this answer. And then you have to see if this quadrant 2 answer is even realistic. Is it even possible? And when you check what the first angle was, so if angle C is 48 degrees and that's locked in, could your next angle be that big? Well, it looks like yes. Because if you had a triangle that had an angle C of 48 degrees and an angle A of 102-ish degrees, there'd be leftover degrees for a third angle. So guess what? This could be angle A, but so could this. They are both valid answers for angle A. So we're going to have two totally separate triangles as solutions, two separate solutions, okay? So both of these are going to be good. So angle A could be this or it could be that. Which leads to, next, you would find like the third angle. So in one triangle, if this is angle C and this is angle A, then angle B, the third angle, you know, like the rest of the 180 degrees. So you would just subtract this and this from 180 to get that. But if you chose this instead, you would have 48 degrees, 102.089 degrees, and when you subtract those two from 180, you get that. So those are my two possible angle B's. And then for little b, well, if this is my big A with this as my big B, you have to do a full law of sines proportion to get this as your little b. So again, for this solution, where you go with 77.911 for big A, and that would be your big B for this big A, and then you'd have to do all of this, you know, plug in this big B here, okay? And when you solve this one for little b and you let your calculator do this, you're going to get 20.707. But if instead you choose, if this was your big A, and I guess more specifically, if this was your big B, then doing this law of sines proportion where this was your big B instead, you would get 12.749 instead. So those are your two sets of answers. And again, it's like all these three go together, and these all sort of spin off of like choosing this as your big A, and then all these answers pretty much happen from letting this play out, you know? And in this example, if they give you little a, little b, and little c, no matter how hard you try, you know, you can't do a law of sines that's going to get you anywhere. So we need to do the law of cosines. And I'll say this right off the bat, that like if what you're starting off with needs to be the law of cosines, then I highly recommend planning on doing the law of cosines again to find the next thing. So since that's going to be our strategy, it really shouldn't matter which angle we find first here, because in this situation we pretty much have our choice. We could find big A first, we could find big B first, or we could find big C first in this situation. But I'm just going to go kind of like in alphabetical order, and I'm going to find angle A, because it doesn't matter as long as I'm planning on using the law of cosines again right next. You know what I mean? So letting this play out, plugging in what I know. 17 squared is 289. 45 squared is that. 30, oh, I'm sorry, no it isn't. Let me repeat that. 45 squared plus 32 squared is going to be 3049. Okay, so again, I did a couple things at once. And so 45 squared plus 32 squared will equal this. And then 2 times 45 times 32 gets you this, or maybe I should say negative 2 times 45 times 32 gets you that. And what do you do next? Wouldn't you now want to subtract 3049 to the other side? And you would get this. So 289 minus 3049 gets you this. And that sets you up to divide both sides by negative 2,880. So again, we're dividing both sides by negative 2,880. And that's going to get cosine of A by itself. We can't get big A by itself, you know, the old-fashioned way, but we're going to get the cosine of A by itself, and then we're going to do the inverse cosine of this fraction. And you might notice right now that this fraction is going to be overall positive. A negative divided by a negative will be overall positive if you want to like take that into consideration as you plug this into your calculator. But anyway, the inverse cosine of this should get you about 16.598 degrees. So that's angle A. And then, like I said, what you're going to want to do is the law of cosines again to find the next angle. And so I'm going to go after big B. It doesn't really matter, though, which one you find next. Just like it didn't matter which one you find first, as long as your plan is like a double law of cosines. And so 45 squared is that. I'm going to go ahead and, like I did before, just do 17 squared plus 32 squared. And that's going to be 1,113. And then the minus sign comes down, and I'll just say 2 times 17 times 32 is 1,088. Same steps. We're going to subtract 1,313 to the other side. And then we're going to divide both sides by negative 1,088. And that gets the cosine of B by itself. And then the next step would be to, what? Take the inverse cosine, which should get you that from your calculator. And then again, just like the first problem on the sample test, when you have 2 out of the 3 angles you can get the third angle just by subtracting both of these from 180 degrees to get what's left over. And I don't know why, I just noticed this. It's minor, but you should have degree symbols because those are degree measures. And that's number 3. I guess one final comment while it's on my mind right now. Only one answer, right? Only one answer, because doing the inverse cosine, yes, there's infinitely many answers. Yes, there's 2 answers, as you go around the circle for the first time, in between 0 and 360. But, I mean, up here, like for big A, it was like quadrant 1 answer, and there also was going to be a quadrant 4 answer. But like I've said in class many times, or at least a couple times, quadrant 4? Like, there's no way that a quadrant 4 angle could be in a triangle. It's way too big on its own, right? Think about it, a quadrant 4 angle. So yeah, there's no point whatsoever even checking what the quadrant 4 answer would have been for big A, because it's nowhere near realistic. So one answer and only one answer for number 3. Next, okay, now we're changing gears into like section 3 and beyond, So I guess those first 3 questions pretty much only cover section 3.1 and section 3.2, and now this is where we changed gears as we got into section 3.3 and polar coordinates. So first thing I want you to do is plot it. And so remember how I said you want to find the angle first. So 240 degrees is clearly right here. And then the radius is 2, so 1, 2 right here. So that's 240 with a radius of 2, so the second circle for the radius of 2. And that's where you should plot the point. And I hope we're reading directions, because this is kind of like a 2-part question. Good thing I have this here to help remind you that there's some other answer we need to do, not just plot it, but give the final rectangular coordinates. And, whoa, speaking of, well, I guess I will emphasize this for sure. Maybe I didn't need to emphasize that this was a 2-part question, because this answer space is clearly right here, but the final rectangular coordinates is key here. All right? But the first thing you're going to do is find the... oh, wait. Never mind. I'm thinking of something else. I'm thinking of rectangular form. Yeah. I'm thinking of this, where... See, that's why I already have this underlined in number 6. So never mind, I'll reemphasize that in number 6, because of course it's going to be rectangular coordinates. That's kind of the only thing we can do. So what are we going to do to change? Let's see here. So my r equals 2 and my theta is 240. So I'm going to find x by doing this equation. X equals r cosine. Okay? And so you plug in what you know. And then you go to your cheat chart to find the cosine of 240, which is -1/2. And so your x coordinate is going to be -1. 2 times -1/2 is -1. Likewise, kind of thing, you're going to find your y coordinate by doing this equation. And so look, you're going to have to probably memorize those 2 equations, right? That's 2 of the things you're going to have to kind of memorize. And then your cheat chart says that sine of 240 is that. And so your final y-coordinate is going to be negative root 3 when you do this, and you simplify it to negative root 3. So that's the final answer for number 4, along with the graph. Number 5, another two-part question. They want us to plot the complex number first in the imaginary plane here. And since root 3 is approximately 1.732, that means we're going to go, let's see, so like on my real axis I go to 1, and on my imaginary axis I go to negative root 3, which is like, I don't know, there-ish, as long as you're pretty close. So that's part 1, it's part A, done. And now we're going to have to write the number in polar form, and that's obviously going to go in this final space right here. Okay, so what do we need? We have, basically, what we have is, well, I thought it was going to say basically this, that A equals 1 and B equals negative root 3, which that helped me plot the complex number, to be honest. But so if we have A and if we have B, how are we going to get R and theta? Because that's what we need ultimately. We need R and we need theta to plug it into this polar form of a complex number. So given A and B is just like given X and Y, essentially. And so we're going to use basically the Pythagorean theorem to get R. So I plug in what I know is A and what I know is B. And so negative root 3, or squared is 3, and then 1 squared's 1. Take the square root of both sides. Technically, you get plus or minus 2, but of course we're going to go with positive 2 for our radius. And then here's how we get theta. We use that equation. Again, having A and B is just like having X and Y. And so, what's going on here? All right, come on. So you plug in for B, you plug in for A. That simplifies just that. So now you can easily check your cheat chart. And there's 2 angles that you have to choose between. And obviously, with my point being here in quadrant 4, obviously we're going to go with 300 degrees and not 120 degrees, because just look, we got a positive A value, a negative B value, and that totally corresponds with an angle like 300 and not an angle like 120. And so now that I know that R equals positive 2 and theta equals 300, I can plug into my polar form here, and my final answer is right here. Moving on to number 6, where we want to find the product of a couple complex numbers in polar form. Now this is where I clearly wanted you to see and notice that, don't want to miss that part of the directions. You're going to leave your final answer in rectangular form. So make sure to read directions, people. Now, this formula for a product, Z1 times Z2, this should be on your formula sheet for sure, at least the way I'm doing things in 2018. So you're going to have to just look at your formula sheet and find the formula, and then when you plug in, it's going to be 5 times 10, because this is like R1 times R2, and this is going to be theta 1 plus theta 2. And so when you simplify the formula, right, you plug in and then you kind of just, 5 times 10 is 50, 20 plus 25 is 45 degrees. But this is not your final answer because this is not rectangular form, it's polar form. So do you remember how I mentioned in class to go from polar form to rectangular form? Remember, rectangular form is A plus BI. So how do you take this and convert it into this form? Well, all you really do is we're going to do the cosine of 45, and we're going to do the sine of 45, and that'll be root 2 over 2, and again, root 2 over 2, same thing, right? Cosine of 45 is root 2 over 2, so is sine of 45 root 2 over 2, and then the final thing you have to do is distribute the 50 through that bubble and get a final rectangular form answer of 25 plus 25I root 2. Next. Find the absolute value of that complex number, which is in rectangular form, by the way. Remember that technically absolute value always means like the distance from 0, or the distance from the origin, I guess, in this case. And so what that basically amounts to, long story short, is this formula, which is essentially the Pythagorean theorem. Okay, so I think you're going to have to remember this. I don't think this will be on your formula sheet, so you're going to have to know that you're going to have to pretty much bust out this Pythagorean theorem to get the absolute value of a complex number, like negative 4 plus 2i. And so what is A? Isn't A negative 4, and isn't B positive 2? And so you just plug the stuff in. Don't forget that negative 4 squared is positive 16. And so that gets you root 20, but can we stop with just the square root of 20? No, because that can be simplified. And this is the way I do it. I break off a perfect square, and we take the square root of that. And so the final answer, the bestest answer for full points, is 2 root 5. Number 8 wants us to do the, we want to raise a complex number that's in polar form to a power. This is like me saying, now watch the mouse cursor carefully. It would be the same thing if I were to say that z equals what's inside the brackets, 2 times the cosine of pi over 10 plus I sine of pi over 10. So that's what z equals, the stuff inside the brackets. And then I were to ask for z to the 5th power. But putting this in brackets and then raising the whole thing to the 5th power, that's of course asking for the same thing. Now the first thing is that we probably would rather say what pi over 10 is in degrees, which of course is 18 degrees. And now we look at the formula sheet, if you have to remember like how we find, z to the nth power. Remember how it's like, this formula where it ends up being, okay, so that formula. And so all you have to do is plug in 5 for n, like here, here, and here, and 18 degrees in for theta. And so you end up with that. So 2 to the 5th power is 32. And then 5 times 18 degrees is 90 degrees. But I guess you could have kept it in radians. You didn't have to turn pi over 10 into 18 degrees. You could have kept it in radians, and pi over 2 would have been your final theta in your answer. But chances are you're probably going to go with that. Okay? So that's how simple number 8 is. Number 9 wants us to find all of the complex cube roots. And so this is where we use this formula, which fortunately is on your formula sheet. And so we're going to, let's see here. So this is like my R. Let's write some stuff in, I guess. So that's like my R. This is like my theta. And if we're finding all the cube roots, that means n equals 3. Because we're finding all the third roots, or cube roots means third roots. So R is 27, theta is 150 degrees, and my n is 3 because those are the kind of roots we're finding. Now the only other thing to be aware of in this formula is your k. Well, we're going to find multiple roots. Since we're finding all the cube roots, all the third roots, that means there's going to be 3 of them. Okay? That means there's going to be 3 of them. So we're going to do this formula 3 times. All 3 times we're going to plug in the same theta and the same n and the same r, but we're going to plug in a different k value each time. And we're going to start, we're going to start by plugging in 0. So if we want 3 roots total, essentially z sub 0, z sub 1, and z sub 2, and there's not going to be a z sub 3, z sub 4, or z sub, right? There's only going to be 3 roots. So we're going to use k equals 0 to get this guy. We're going to use k equals 1 to get this guy, and we're going to use k equals 2 to get that, because 0, 1, and 2 make a total of 3 roots. Alright, so let's see here. So this part, we have to do the nth root of r, so the third root of 27, and that's always going to be 3, right? And then letting k equals 0, this part of it, where you do theta plus 360 times k all over n, if you let k equals 0, then all this is going to equal 50. When you let k equals 1, this final angle part is going to be 170. And if you were going to let k equal 2, 150 plus 360 times 2 all over 3 would equal 290. Okay? So this answer for each root, is always going to be 3 out in front, 3, 3, 3, okay? But this is going to change, and so when k equals 0, then this whole thing was 50, so 50 and 50. And then when k equaled 1, then this and this were both going to equal 170, and then 290. Number 10. Convert the polar equation to rectangular. Okay, well, here we go. So we have to change an equation that involves r and or theta into an equation that involves x and or y. What are we going to do here? squaring both sides would make the left side into an r squared, which is good, but that doesn't help on the right side. So here's what we're going to do. We're going to multiply both sides by r. That's the first step. Because that would also make the left side into an r squared, but better yet, it would make the right side into this. And if you have an r sine of theta, what could this be replaced with? Like I already said that what? Or maybe I didn't already say it. R squared can be replaced with what? Involving x and y. That. But what can r sine of theta be replaced with? What could we replace the r sine with? We could replace it with just y. Okay? And so here we go. Guess what? Right there, you'd be able to stop and get full points. But just like I said in class, right, if you keep this going and you put it into circle form, you can get bonus points. So here's what we do. We get this 8y term over here, and since it involves y, it's going to go with the y squared. And now what you have to do, remember, is complete the square. Like, what could you add to this bubble here? You know, add inside the bubble here. That would make it a trinomial that you could unfoil into the same two bubbles, you know? In other words, you know, what could you add in here that would make it a perfect square trinomial? And it turns out that number is 16. That magic number is 16. Remember, all you have to do is divide this number by 2 and then square it. And so I'm going to add 16, but I have to do it to both sides in order to make it legit and legal and everything. So I add 16 here, but you also have to add 16 to the other side. And now what that means is this can be unfoiled into y minus 4 times y minus 4, which means it could just be written as that. And this is circle form officially. And if you have your final answer here looking like this, you will get bonus points. Final problem. How do you turn an equation like this into rectangular? Well, you take this approach, and since theta is equal to 5 pi over 4, which, what's that in degrees? Did I change it to degrees here? No, I did not. You could have changed this to degrees, which is 225, I believe. 225, is that right? Yeah, so this should be 225 degrees if you want to change it to degrees. And then what is the tangent of 5 pi over 4? You can check your cheat chart. Oh, there I go. You can check your cheat chart and it would just be 1. But remember, you're supposed to solve these guys for what if you can? Solve it for y. And so your final answer for full pointage is y equals x. And that does it for the Unit 3 sample test. Thank you, Mozart.